11.3b. So you have four situations, and the first one, a colleague went to the Lego.com website in February 2024 and recorded the number of pieces and the sale prices for 157 Lego products listed there. The equation of the least squared regression line turns out to be, so I'm going to write this up here, C equals 8.94 plus 0.205p. So each one of these questions is just a true or false, and some of them are a little bit tricky. So, A, the Legos cost 8.94 cents a piece. False. You had a 50-50 chance, Blake. So, what is the 8.94? What's that? It's, yeah, the base price that for the box and the shipping, right? That's the y-intercept. So B, for each additional dollar in price, the predicted number of pieces in the set increases about 0.205. So for every dollar, does the price increase about 20 cents per piece? No, that doesn't make any sense at all, right? So this is pieces, and this is in dollars. So this says the packaging and the shipping is about $8.94, and then each piece costs about 20.5 cents. Okay, so A and B are both false. C, for each additional piece in the set, the predicted price increase is about 20.5 cents. That's the one you're looking for. So C is true. D, the price goes up 8.94 cents for each additional piece. False. The predicted price for a set with 0 pieces is $8.94. True. Well, right, that's packaging and shipping, and obviously that's not going to happen. But if you were to follow that scatter plot, if you were to draw the regression line on the scatter plot and follow it back, you end up with about $8.94 for the box. Okay, and Lego people are weird. They probably pay that for a box with no pieces in it. You should see how much money my brother spent. I mean, probably 10 grand on Legos. Yeah, there you go. Okay, F. The predicted price increases by $2.05 for each additional 100 pieces in the set. Yeah. If it's 20 cents per piece, and, oh, that should be, nope, the answer is false. Oh, let's change it to 10 pieces in the set then. So I think this is my mistake. Sorry. All right, G. 89.4% of the variability in price is explained by the least squares line with the number of pieces. False. 8.94 is how much the box costs. H. 83.2% of the variability in prices is explained by the least squared regression line with the number of pieces. That's the one that's true. Okay. People pay attention sometimes. Okay, I. 84.9% of the prices land on the least squared regression line. False. That is not true. The least squared line correctly predicts the price for 84.9% of Lego products. False. Right? 84.9 tells you how much of the variation can be attributed to the number of pieces. If a kit has 354 pieces, it is expected to cost 81.51. How are we going to figure that out? So we type in 8.94 plus 0.205 times 354, and I get 81.51. Okay? L, if a kit costs $25, it should have about 78 pieces. So if we were to plug 25 in here, and we subtract 8.94, and then we divide by 0.205, I actually get 78. But what's wrong with that? Linear regression equations don't work in reverse, right? So if we had our football here, and this was our linear regression line, this line uses x's to predict y's. But you cannot use that equation in reverse, because if we flip the explanatory and response variables, we actually get a new line that looks like that. So the blue line goes through the center of every column, and the red line goes through the center of every row. And that red line uses y's to predict x's. And again, I didn't know that until I took class number 5, which is kind of embarrassing. But it's crazy how much variation there are in stats classes. Like, there are all sorts of things last year we taught that we're no longer teaching, and there are things this year that we're teaching that were never in any of the other stats classes. So it's pretty interesting. So in general, if you are given a regression line, it's going to be the predict y using x. We call that the y on x line. And it does not work in reverse. All right, the correlation coefficient is 0.912. How do you find the correlation coefficient? Well, the correlation coefficient is r. So if we know r squared, we take the square root, and it ends up being, yes, it is 0.912. Okay, any questions? All right, get to work.